This time we'll see how we can install a local version of Kubernetes inside of Ubuntu. Canonical is giving us an option called MicroK8s. I find it very powerful, and it has almost all the features of a modern Kubernetes distribution. So let's see how we can install it under Ubuntu. It's distributed as a snap. So we can go to our terminal and we can use a snap to install MicroK8s. We'll use the most recent version, and that's why it's this flag add. And I have it here already installed. Once it's installed, we can launch the MicroK8s by typing MicroK8s start. It will perform its scheduling, initialization of different pods and services, namespaces also, and we'll be able soon to access it. As you can see, the distribution is also creating new network connections, and once it's started, we can inspect the installation. So we'll type MicroK8s inspect, and it will inspect whether the running services are correctly performing. Keep in mind that all those operations might take time depending on your hardware configuration. So we see that we are advised to enable the forwarding rules inside of our firewall. So we'll do this right now. And the other stuff is working correctly. Key, if again we'll type MicroK8s and then press the tab, we see the options we can use inside of this. So we can type, for example, config, and this will show us basic information on our cluster. So we can access the information via this URL. We also have admin as a username, and we can use this for a password. For more verbose output, we can use get all and then all namespaces, this command. And actually, we can see that we are having here the namespaces, here the different pods. We have enabled certain services, and so far we have most of them running. Also interesting is that all those pods can be accessed via those IP addresses. And of course, we have to use the ports for each of the services. Also, we have deployments where all those pods reside, and replica sets. All right, and so let's type MicroK8s status, and we see that we have the following add-ons here, and some of them are enabled. Let's see how we can access the dashboard. We'll just type MicroK8s enable, and here we'll enable the dashboard. Then we would like to have DNS, and also we would like to enable this metrics server, and that's all you need to do, and this will apply all the needed configurations and also set ConfigMaps and deployments and run the services into our cluster. When everything is enabled, we can again check using this command kubectl get all namespaces to make sure that our containers and services are available. Okay, let's try to access the main service Kubernetes. We'll go to this IP address, and we see that we are required for a username and password. We'll use the username and password from the config command. All right, we enter inside, and we have access to our APIs. Okay, let's try to access the dashboard. So the dashboard is on this IP address. Let's place it here. We'll form an HTTPS request, and we see your connection is not private, advanced, proceed, and we are here inside of the dashboard. For here, we will choose to log in via token. Let's see how we can get this token. Okay, we'll use the following command, kube control with the namespace of kube system. Let's get all the secrets. This will give all the secrets to our different services. We see here controller. So here we'll see the Kubernetes dashboard, the token, and we would like to get the token for this service. We'll use the same command here, but instead of get secret, we will type describe secrets, and then we'll use the name of the service we would like to access. And actually, this is our token. We'll copy the token and we'll enter it inside of the dashboard. When we click on sign in, we see that we are inside of our cluster. And here we can inspect further on the things which are happening inside of the cluster. We see certain events and we have a visual representation of the cluster. If we just would like to stop the cluster, we will just use the same command, MicroK8s .stop, and this will automatically do the things for us. Let's see how we can create one Node application and place it inside of a Docker container, and afterwards manage the application inside of Kubernetes. Right, so here is the directory of our project. Let's take a look at the files inside of Visual Studio Code. All right, let's start with our application. We are using Express, and we have a little configuration for our simple Express application, on which host it will run, on which port. Afterwards, we are creating the application using the Express framework, and when we are requesting the root domain URL, we are sending hello world. Actually, afterwards, we are listening on the port and the host based on our configuration, and if everything is okay, we write to the console that our application is running on the current host and the current port specified. So it's a pretty simple application. We have created also a package JSON where we are starting this application with Node and the name of the JS file, which is server app.js. And also we are requiring Express in the dev dependencies. And that's it for the application. And now let's take a look at our Dockerfile. So in order to containerize this application, now we're using the slim version of Node.js. So it's very lightweight image. And then we are going inside of the app directory of this image, and we are copying our package JSON, so the local package JSON, inside of this directory. Okay, so the npm install will read the package JSON and will install the proper packages which need for our application to function, and then the resulting information we will copy into our container. The last command is just to start our application using Node. So this is our Docker file. We don't need to expose ports because we'll do this later using Kubernetes. Okay, so we save the file and let's create an image out of it. So we go to our terminal. All right, so we'll go to our application, and here we will build our image. So for the build process, we are using the current context. So we will start from the local app directory. We don't want those files to be included inside, just our application. And then we are tagging the application with the following name. And also we're using version 1 of our application. All right, probably some network errors. Let's redo the command. And now we see how initially we'll be pulling the Node image, and out of it we'll run our configuration. One more thing to mention while waiting for the download of the different slices of the images. If we go back to Visual Studio Code, we have placed one file Docker ignore, which is important. Actually, we would like to ignore Node modules, Docker Compose, Dockerfile, and everything what we have in our Git repository. Why this is important? Because afterwards, when we create the image, we would like this image to use its own Node modules to create this directory for itself, not to interfere with the Node modules which we have installed on this system locally. The same is true. We don't want to include those files inside of the newly created image. So now we'll go back to our terminal. All right, the image has been downloaded from the Docker registry. And now inside of the container, we are copying our package JSON, running npm install, and copying our application inside of the app folder, and then we're running this command. The image is built, and this is the ID of the image, and is also tagged, so we've given this tag to the image. One more thing to notice here is that we're using multi-stage building. This means that we have initially a node image, then we are removing this container with this image, and then we are using just the resulting files to serve our application, which saves a lot of space. Let's now try to see if our image works correctly. Actually, we'll use the docker run command. We'll map the internal port of 3000 to externally, again, the same 3000 port. And this is actually the name of our newly created image. Okay, so we see that the container is running, and this is the output from our application. Let's try to browse it now in Google Chrome. So if we go to localhost and port 3000, we should be able to see the output from our application, which was set exactly here, hello world. So the image works. This is an essential step before trying to orchestrate the container. Okay, now we'll open another terminal because I would like to stop this container from running. So type docker container ls, and then I'll stop the container by typing docker container stop, and then the container ID. And we'll see that here the command prompt will be released as long as this command finishes. All right, so the image is tested and it works correctly. The next step is to extract into archive our currently created image. So we will use the following command. Actually, we'll grab the newly created image and we'll save it into myimage.tar archive. We are doing this step because afterwards we'll use this archive and we'll push directly the archive into the Kubernetes image repository. Let's see, here is our image, and yeah, it's around 174 megabytes. So let's go to our MicroK8s and start the cluster. And the next thing we would like to do is to enable certain add-ons. So we'll enable a DNS and a registry. The DNS will be to be able to communicate between the different containers and pods we're about to create. And the registry will also use the storage. And inside of the registry, we'll be saving our Docker images. We just created one. So we see that both of them are enabled. We can see this in the status, the registry and the storage, and also the DNS. Okay, it's good from time to time to check the status of our node or our machine where those add-ons and services and pods are running. So we'll type kubectl describe node, and we see node ready, so we don't see any errors. If you see here a disk pressure or any other error, you have to clear this error before continuing on. And now actually we would like to see what's inside of our container registry. So what we have as an images inside of a MicroK8s installed by default. So we'll use container daemon CLI for this. So type ctr and then image and then list. Reduce a little bit the screen size and the font just to be able to see. So those are the default installed images which we have, and our goal is actually to place this Docker image which we have right now saved as a tar archive inside of our Kubernetes in order for the Kubernetes to use it. Of course, there are different ways to perform this. I've chosen this one. We can just use the same command for image and then import, and then we'll choose our archive. It's inside of local app, myimage.tar. So once again, it will import our Docker container in the image registry of Kubernetes. and the operation may take a while. All right, it's ready. Let's again check what's inside of our image list, and we should be able to find our new image here. All right, here is the image. This was our tag, and we are now sure that it's inside of image registry, inside of Kubernetes. All right, afterwards we'll return to our previous directory, and here we have one file, a NodePort, which we'll use right now. Here is the full version of the file. Actually, don't be scared of what is written here. We will use this file in order to grab the image from the registry and to create a container and to place this container inside of a pod. So that's what we would like to achieve. First, we are specifying the API version, then that we are going to create a pod and the name of the pod, the labels or how this pod can be recognized, and here are following the parameters of the containers. The name of the container is simple API. This will be pulled from our registry. This is the same name as here we are having already inside of the registry. And then I have just limited the storage which the newly created container will require. Those lines can be directly deleted. They are not essential for the setup. And also we are opening port 8000 for communication. This line, of course, you can remove it also. All right, let's now run this configuration. We'll go to terminal, and here again we'll use MicroK8s, and then I use kubectl, and then I'll apply the following configuration. So this is the manifest file of creation of one pod. So I'll apply the file nodeport.yaml, and of course I have to specify that this is a file configuration which I'm about to apply. And we see that the pod has been created. And now it's very important to follow actually what is happening on the creation of the pod. For this, I've used the following command. Here we have a log, and this is our pod, and it's in a state of running. This is what we are trying to achieve. If you have a different result here, I advise you first to get the ID of the pod. And so we have its name here, and then to describe it again with MicroK8s kubectl and describe pod, and then the name of the pod. And this will give you a lot of debugging information about the pod. For example, which image has been loaded inside of its container, the configuration, and those events here, you can orient yourself if you have certain problems here to correct them. You can also use the logs command to see what is happening inside of the pod, or to set up more verbose output to the same command with this parameter, which will enable you to see every step of the running of and starting of the container. So here we see that we are requesting the pod with our image inside and the response from the pod. Finally, our response from our application. Keep in mind that this is isolated environment, and let's not forget to mention that by knowing the name of the pod, so it's a simple API pod, we can enter inside by using again kubectl and then exec -ti for interactive shell, and the name of the pod, it's a simple API pod. And then what we would like to run as a command, so it will be bin bash, and this way we are inside of the container residing inside of this pod. So we can make changes here, such as installing applications or testing the network. And this is very useful for debugging of our container. We exit from here, and now we'll see how we can show the information from the pod into our browser. Since we know that the application is running on port 3000, as we have it in our server app, so it's listening on port 3000. We would like to expose this port from the protected pod network environment to outside, so we can browse it in a local host. This we can do again with MicroK8s kubectl, and then we'll do port forwarding, and then we'll specify which port we would like to port forward, and then the port we would like to expose and to forward outside. So anything that is requested at this address will enter inside of our port, and we will show its contents of port 3000. Okay, so let's go to this address with our browser, and we see this hello world, and this time it's running directly from our Kubernetes setup. Here in the output, we see handling connection for port 3000. All right, so that's basically, guys, how we can handle pods. In real life, those are grouped into deployments, and those deployments are exposed as services. But it's always good to know how to go deep down into the container and debug certain things for yourself. This time, we'll be looking at how to create our own deployment and how to create a service which will expose this deployment for outside world. At the same time, we'll start working with the integrated registry which Kubernetes offers. Okay, let's take a look at our current configuration. And so we see that we have enabled the registry add-on as well as the DNS add-on. We can do this by just typing MicroK8s and then enable, and then registry, and then DNS, and this will enable those two important add-ons on which we'll build our application. It's important to make sure that the registry add-on is installed, and we see here the name of the pod the registry is running, so the status should be running. And by entering in the container registry namespace, and then we can describe this pod here. So I'll just paste the name of the pod, and we see from the log that the registry is running, and you can follow the events just to make sure that everything is all right. You might experience problems with using different versions of the IP protocol. In those cases, I will just advise you to edit your host file, and just here to comment the IP version 6 support for the local host. This will enable your local registry to listen properly on the local addresses. Actually, we can check what is listening on port 32,000, and we see that we have correctly listening our service registry on this port. And the next thing is to go and grab the IP address on which we can access the registry. And so again, we'll get the information for our namespaces, and we see we have this cluster IP address, and we can access it locally on port 5000. So let's go to our browser and access the registry, and we see that it's running. We can get a catalog of our images currently in our registry by adding v2 and then catalog. And this is the registry which is supported by Docker. Okay, this is the container registry. And right now we have emptied its contents. So there are no repositories, and let's see how we can push our Docker image inside of this registry. Okay, the next step is to see what kind of images we have already built. So we can type Docker image list, and our next goal is to push this image with this tag into our Kubernetes registry. So we will just type Docker push, and then we'll paste the name of the repository and the tag name. So this will connect to our Kubernetes registry, and we'll push the different layers from our image. So we'll wait for the process to finish. We see that the operation completed successfully. Now, if we go back to our browser and issue the cluster IP address of our registry, following the port, and get the catalog of our repositories, we see that our image is here, server app. We can list the tags of this image just because we can have more than one tag of a certain image. And by issuing this command, we see that we have a server app image with a tag v1 listed inside of our registry. The next thing we'll do is to use this image from the registry, and we'll create a deployment. So we'll start Visual Studio Code from the current directory, and we'll take a look at the file node deployment YAML. It's very convenient to start reading the file from the bottom to top. Basically, we are creating one container using this image that we just pushed inside of our registry. We're opening container port of 3000, and we are naming the container as simple API. For this container, we are also creating a label app equal to simple API. Based on this template that we can create multiple copies of these containers, we are creating replicas. By increasing here the replicas, Kubernetes immediately will scale up our deployment. And here is also information about the deployment, its name. It has a label of simple API, and we say to match all the replicas with the same label, and the replicas will match the containers with the same label. This means that we're creating one deployment which will be responsible for creating replicas, and they'll be responsible for creating containers with the following specifications. All right. After we have our node deployment, we can go to the terminal and run the following manifest file. So just type MicroK8s kubectl, apply, and here we'll use node deployment. Of course, -f for the file. We see that the deployment is created, and now we can take a look at the status of deployment. All right, sometimes you might experiencing problems by starting the deployment due to the problems with the registry. I advise you to enable packet forwarding with IP tables with the following command. Also, sometimes the Ubuntu firewall can cause problems, so allowing incoming and outgoing traffic on the bridge interface should help. And the last thing is to enable the routed protocol, so this line of code will also help. If this doesn't help, you can just restart the Docker daemons with the sudo system control, restart Docker. And the point is to reach to a state of a running container of our deployment. Now we can actually take a look once again at its configuration. And we see that this deployment runs inside of our Kubernetes cluster, but we cannot reach it unless we enter with a shell directly into the container. So basically, by knowing the name of the pod, we can easily just use MicroK8s kubectl exec, and then interactive terminal, and then the name of the pod, and this is our pod. So we'll paste the name here, and then what we would like to execute, we'll use bin bash. Okay, so this will allow us directly to enter inside of our application pod, and we see our application here running. Right now, this happens inside of the pod. Let's see how we can expose certain IP address outside, so we can take a look at the application inside of our local machine. For this, we'll use the so-called service, and here we have such. This is our node service. Important thing to notice is that we are selecting to expose only deployments which have a selector app equals to simple API. Here in the deployment, we know that this is our deployment. So with the service, we'll expose the deployment. We are using not cluster IP. Cluster IP means that we're exposing only one IP which can be dynamically changed. Basically, the main service of Kubernetes here can be accessed with this IP and with this port, but we'll be using something different. We'll be using a NodePort, and with target ports, we are accessing the internal port of the application. So our application is exposing port 3000 and listening on this port. And we would like inside of our service to map this port to port internal port 30,000. And now let's try to apply this node service. We'll use again the same MicroK8s kubectl apply -f, and then a node service YAML. At the same time, we'll take a look at what's happening here. So from the output, we see that we are exposing our node deployment using our new service on this address with the port 30,000. Okay, so let's go and try to access this IP address on port 30,000. And we see the application here is working correctly. This is within the Kubernetes deployment exposed as a service. From the command prompt, we see that we have another port here. And the second port is the NodePort. Actually, this is the port of the local machine where our Kubernetes cluster is running, on which we can access the service. Since we are running on localhost, the same service can be accessed on this port. And as you can see, accessing localhost on this port, again, redirects us to this service. And one more thing, if we go and ask for our endpoints, so we'll type MicroK8s kubectl get endpoints, we see now a third way of accessing our application. So just to demonstrate this, we'll just go in the browser, paste the address. Again, the same application appears on a completely different IP address. So what's the difference between those three addresses since they're pointing to the same application? So basically, this cluster IP is based and binded with a port 30,000. This is internal port. So how other services, if we have, for example, database service, they can connect to this IP in combination with this port. The next port, 31,859, we can find it accessible in our local host because this is externally open port. This means that it's visible from outside of our host. And the third port, which is interesting, is this target port. This is actually which port inside of our container we would like to target and expose through those two ports. The reason why we're using services, and actually we can run this command once again, get endpoints, is because we would like several IP addresses with their combination of their ports to be responsible for a single named service. In this way, we can have multiple machines and containers and pods which are responsible for a single service and ensure high availability of this service. All right, guys, that's for now. I hope you enjoyed the tutorial. You already know how to create deployments and then how to pair them with services in order to expose the deployments for consumption. We'll take a look on how to create a horizontal pod autoscaler. It's a very useful concept which allows us to, whenever we have higher load of our application, so a lot of requests and the current pods which the application is running cannot handle the load, Kubernetes will automatically scale up the application by running it on multiple pods. And then when the load decreases, Kubernetes will scale down the number of pods. We can use directly the walkthrough from Kubernetes here on this page. For this, let's go to the terminal. And here I've prepared one autoscale application. And basically, it's one loop, a very long one, which calculates and adds to the value of x square root of certain value, and afterwards it writes operation complete. So this will be something which will put a load on our server. And then we have one Dockerfile, which actually grabs the PHP Apache image with the integrated server and place this file inside of the image. We'll have an image with this code inside and a live web server where this code can be run on port 80. Because this is the port which this image exposes. Now we can start MicroK8s and we will enable certain services. If we type status, we'll see that we have enabled here DNS as well as a registry. These are important. Actually, you can enable them by using this command. All right. So here we have a Dockerfile, so we can Dockerize our application. by just using this command. So we're building an image from the current context, so from those two files, and we are tagging the image with this name PHP app and the tag v1. And it's important to notice that the name of the image starts with localhost and the port 32,000. That's important because our registry is listening on this address and port. So later when this image is ready, we'll be able to push it into our registry. I've already built this application. Actually, if I type docker image list, we'll see the image is built. All right, the next step is to push the image into the registry. So type docker push, and then we'll just copy the repository name. And we see that our localhost registry path is not functioning. Let's check what's happening. We'll type MicroK8s kubectl get all namespaces, and we see that the registry is not loading up properly. Also, we have problems with the host path provisioner, and let's see how we can solve them. For the registry, we'll allow certain ports in our firewall. We allow the routed protocol, and we allow the IP tables forwarding policy. And now we can disable the registry and enable it once again. All right, let's again check the status, what's happening in our namespaces. Okay, this time the registry is in pending state, so soon it will be available. And we'll restart the Docker daemon. So type sudo system control restart Docker. And the next time we'll check, we'll see that now the status of the registry is that a container is creating. Actually, we can grab the pod name of the registry and inspect with MicroK8s kubectl describe, and we paste the name of the pod here and the namespace, which is container registry. This will show us the log of what's happening in this pod. We see that right now we are pulling the image from internet for the registry. That's why we need to wait a little bit before the container gets ready, and the pod is also ready to be used. We can check this here. We see that the container registry is ready to be used. We can also remove those evicted pods from our node, so we can delete them one by one, or with this useful command, which will basically go through all the pods which are labeled evicted, and we'll delete them afterwards with MicroK8s kubectl delete. All right, so now the output should be clean. We have our registry and the DNS running correctly. Let's return to our application and try to push our image into the container registry. And we see that the operation is successfully being performed. All right, the image is pushed into the registry. And now let's use this image and create a deployment out of it. Let's see what's in this file, Autoscale. This is our deployment and has a name of PHP Apache. We'll run currently just one replica, so one pod, and we'll use here the image we just created. So this is its name, and we'll be exposing port 80. Apart from the image, we have limits on the resources this replica will use. We have two ways of limiting the resources. Basically, we're splitting the CPU resources in CPU shares, and 1000 millicores represent one core, which is also equal to 1024 shares. So basically, this is 20% of the CPU, and 500 millicores means that we are trying to use 50% of the CPU. The difference between requests and limits, actually the requests are for the allocation of current replica that will be created, so for the current pod. And sometimes if we experience a spike in the traffic, we are setting up limits, and this is here like a hard limit, above which the container will be evicted. So the next thing is we are specifying in the same file a service. So basically we will be exposing the container into port 80, which will be inside of our cluster, so it will not show up outside. This is a very simple way of just testing the container. Also, we see that we are selecting only this service to be for deployments which have a label run equal to PHP Apache, and that's our deployment because we have this label set up here. Okay, let's now run the deployment. We'll use MicroK8s, kubectl, apply, -f, and this is PHP Autoscale YAML. So this should create the deployment and the service, PHP Apache. And we can take a look at the current status of the cluster. We are now just in the phase of creation of the container. All right, we see now that the container is created. It has also cluster IP, and it's exposing 80 port. Now it's time to run our horizontal pod autoscaler. Actually, we would like to autoscale the deployment PHP Apache, which is this one. And we would like to limit the CPU usage to 50% and to use minimum 1 replica and maximum 10 replicas when we have a high load. Okay, the Apache deployment is autoscaled. We can check the current situation in the deployment by typing MicroK8s kubectl git HPA. We see this again, minimum number and maximum number of pods, 1 replica, and the targets for the CPU are here listed. So the next thing we would like to do is to create just one time a running pod, because afterwards we'll remove it with interactive terminal, and we'll load up a BusyBox image inside. So it's a minimal image, and we'll enter into shell. So we'll wait for this pod to be created. Okay, from this temporary container, we'll try to reach with double git to our PHP Apache container. And actually, we see that we have the index.php page generated. This means that we can reach our PHP Apache container. And now let's generate load. Actually, we are browsing from this temporary container our service in order to generate some load. As you can see, we're generating a lot of requests. Okay, the program is running and generating traffic. And here in another tab, I'll enable the metrics server. And this will allow us to be able to track the load over our servers. So I suggest first to get the metrics server running. We see that it's the fact right now. It's running. This means that we can successfully get the HPA. Now we see we have a 0 load, and the target load is 50% on the CPU. All right, let's run again this pod and start again the load over our container. And now when our temporary generator pod is running and we are inside, we can repeat the process of flooding. Okay, so we are generating the requests and we're following here the metrics, and soon we should be able to see that we have some load on our cluster, and we see that the load is increased here to 54%. Now is above 200%, and we see the horizontal pod autoscaler, how automatically we have now 5 replicas. Actually, we also see from the deployments increased number of the replicas. And let's stop the operation now, and automatically we should be able to see a reduce in the count of the replicas we are running. So we see we are reaching the target load of 50%, and this means that our replicas will be reduced. Let's exit from the container, and now we can stop the autoscaling by just deleting the autoscaler. So just type MicroK8s kubectl delete, and we'll just paste the name. And now we see that it has been deleted successfully. All right, in our case, just because I interrupted and deleted the HPA, we'll see that the deployments will stay in this number. So one way to correct this is just to type MicroK8s kubectl scale deployment, and we'll provide the deployment name PHP Apache, and then we'll set the replicas, let's say to 1, and this should restore our replicas. This time we'll show how to perform a rolling update, or the so-called rollout in Kubernetes. This means that we'll create a new version of our one file, and we'll build an image out of this. We'll push it into Kubernetes registry, and from there, we'll update with this image our deployment. So let's see how we can do this. We see that we changed the file to be with version 2 here. And the next thing we would like to do is to build an image out of this new file. So we'll type docker build. From the current context directory, we would like to tag it with localhost 32,000 because this is the host in the port of our Kubernetes registry. And then the image will be with the name app version 2. And of course, here -t to tag it properly. Okay, now we can type docker image list, and we see we have a second version of our image. So now we can push the image into the registry. So we'll type docker push and the name of the repository here. And we don't have connection to our registry, but that's because we haven't started our cluster. And so soon we'll have the registry scheduled so we can push our image. All right, so we can check MicroK8s kubectl get all namespaces, and we see that our registry is running, as well as the previous version of our application running in a pod and made by our deployment. Okay, so let's now repeat the previous command. So we'll try to push the image into the registry. As you can see, a lot of the layers were existing because we were using the same base PHP and Apache image layers, and we are just changing some parts of the file, so they were just pushed. Now we can open in a browser our registry. All right, so we see the cluster IP of the registry on port 5000. So we can also type v2 and underscore catalog, and we see that in the registry we have a repository PHP app. So we can grab the name of the repository and just say tags list. And we see that we have 2 tags in our registry. So the second version of our application has been pushed successfully. Now let's see how we can get the image out of the registry and replace it in our deployment. All right, for this, we'll go to our deployment, and it was PHP Autoscaler. And we would like to change the image here in the container with the name PHP Apache. So we'll start writing MicroK8s kubectl set image, and then we'll specify the name of the deployment. So the deployment name is PHP Apache. Type deployment PHP Apache, and then the container name, which is PHP Apache again. And we would like to set its image to version 2, this image. All right, and we see that the deployment image has been updated. We can also specify kubectl rollout status of our deployment, PHP Apache, and that's happened very fast, our rollout. And also we can specify history here, and this will show us that we have 2 revisions. This means that we can switch between revision 1 and 2. Right now we are on the revision 2. Let's now enter inside of the pod to see the changes. All right, just let's get the name of the pod, and here our pod is this one. Okay, so we can enter inside kubectl exec -interactive terminal, the name of the pod, and here we would like to run bash shell. Right now we see that we are with the new version of our file inside of the pod, so the deployment rollout was performed correctly. Okay, let's show the rollout history of deployment PHP Apache. Here we can return to a previous version, and this we can do with MicroK8s kube control rollout undo deployment PHP Apache to revision, and let's say to revision 1. All right, so if now I see the information about our containers, we see here one new container. So this means that we can enter inside, and this was our previous container. I will just replace the name of the container here, and here if we go and see what's inside of index.php, we see operation complete without the version 2. This means that we did an undo of our changes, and we can exit. All right, let's see how now we can edit different parameters of the deployment. Let's see our deployment, and its name is PHP Apache, so we can type MicroK8s, kubectl, get deployment, PHP Apache, and this with the format of YAML. We can redirect it to, let's say, new deployment YAML. And let's see what's inside of the new deployment YAML. This is the full specification of our deployment. Now we can edit our new deployment. And here, for example, we can change those limits. Let's say we can remove the limits. And basically, you can change everything here. We save the deployment and we can apply it. So MicroK8s, kubectl, apply, -f, and it will be new deployment. And we see that there are some changes into our deployment. If we again get the deployment with the YAML format, we see that there are no limits on the CPU and the requests. So we basically modified our deployment. And that's another way on how you can modify parameters of a running deployment. And the third way is to edit the deployment. So we'll use a nano editor and we'll just type MicroK8s, kubectl, edit, deployment, PHP Apache. And this will open our editor. We can change again, the parameters here. For example, we can change the image version. We save, and this automatically will reapply the deployment. And this way we can edit in place the information. All right, this means that our update should be rolled out. We can see if our changes have been accepted. And we see that we are running the changed version 2 of the image. Okay, guys. That's for now. You saw how you can change your application, create an image out of it, push it into the registry, and perform a rolling update using the rollout command, as well as different methods for changing the deployment configurations. We'll take a look on how to create persistent volume claims. And with those claims, we'll basically reserve space in our system, and we'll use them to store database data. I've chosen MySQL. And next, we'll create one temporary pod, and we'll try to access the MySQL pod. All right, so this is the persistent volume claim. So actually, first, we are creating a persistent volume on the system, and it has a name, MySQL PV volume. We say that we would like to reserve 100 megabytes for the storage area of MySQL. At this space, it will be reserved in mount data directory. And then we create a persistent volume claim. So we say, okay, if in our system there is such space, please, we would like to reserve it and to use it. So basically, right now, if I apply this MySQL PV YAML file, I should see kubectl get pvc. Our persistent volume is created, and our MySQL persistent volume claim is bound to this space, and the capacity is 100 megabytes. Okay, that's where we will store our information from the MySQL database. And now let's see the MySQL deployment. We see that we have one service which is exposing the deployment. We're exposing a deployment with a selector app MySQL on port 3306, and we're looking for such deployment with selector app equals to MySQL. We see that this is our deployment. Actually, it has the same label. So for the deployment, what's interesting is that we are pulling from internet the MySQL image, and we are setting a root password for this image. I advise you, if you are doing this for production purposes, to use secrets, which will not allow to store the passwords in such plain text files available for the administrator to peek around. Then we are exposing the same port out of our container. So this happens within the container. The interesting part is those two sections here. So basically, we're creating one volume with the name of MySQL persistent storage, which will be used inside of the container. And for this volume, we're using already created a persistent volume claim, which is MySQL PV claim. Since MySQL PV claim is bound to MySQL PV volume, we're actually connecting this volume with the reserved space of 100 megabytes on our drive. It's a little bit confusing why so many connections we're making, but in real world, we can have a lot of hard drives and a lot of capacity on different machines. That's why we're creating volume claims in order to reserve the best possible space according to Kubernetes. Once we have created this volume with the name of MySQL persistent storage, we'll mount this volume and we'll mount it inside of the container, inside of the directory of MySQL. So basically we are saying, okay, the MySQL image will load up within the MySQL server, and for its default storage data, which is inside of varlib MySQL, to use our persistent storage. And now if we type MicroK8s kubectl get all namespaces, and we have applied the previous configuration, we'll see that our MySQL pod is running, and we can describe this pod. And as you can see, the port 3306 is exposed. We're using the MySQL 8.0 image pulled from internet. We've set the root password. If we have used secrets, this field will not be displayed to the administrator, but this is just another topic. And under the mounts, we see that we have mounted varlib MySQL. This means that the container will use our MySQL persistent storage for its data, and it's mounted with read-write access. Also, we see that our volume is actually persistent volume claim. And here from the log, we see that the container is started successfully. Actually, if we describe once again our persistent volume claims, we can grab this MySQL claim and describe it. And of course, it has to be of type PVC. And we can see again information about our claim. And we also see that it has been mounted by our pod. Okay, the next step is to access our MySQL pod via another pod. In order to enable the communication between the different pods, I've enabled the DNS add-on here. You can do so with MicroK8s enable DNS. And also you can enable the packet forwarding in IP tables with this line. All right, how to connect to this MySQL pod? It has to be exposed as a service, as we created this service. So we'll type MicroK8s kubectl get services, and this will show us the name of the service which is exposing our MySQL pod, and the name is MySQL. And now I'll paste one long line, which will actually create one temporary container, and with the image of MySQL, with the name of MySQL client. And inside of this temporary container, it will run the following commands. Actually, we would like to run the MySQL client, specifying as a host the name of our service, MySQL. So with this parameter -h MySQL, we're specifying that the temporary pod should connect to the previous MySQL pod using password as a password. And let's execute this command. And we see that we are inside of MySQL. So we can type show databases inside. We can see the tables, and actually we can see our user table. So that's how you connect basically to the exposed service by using its name. And now if we exit from this pod, the temporary pod and container will be destroyed, and we can normally work within our cluster. Let's see how we can build an Ingress controller using Nginx inside of the Kubernetes. And we use the Ingress controller in order to have two different versions of a same application and to be able to serve it to our users via two different URLs. From the status of the MicroK8s, we will need to have DNS and registry enabled. Then we will enable the integrated Ingress add-on. So we'll type MicroK8s enable Ingress. And now we can check the status of our cluster. And we see that we have the DNS here, the registry running as a pod, as well as our Nginx Ingress. You should see them that they are ready and running here in order to be able to proceed further. We can also describe the pod where our Ingress is running. So we can type MicroK8s kubectl describe and namespace is Ingress and the name of the pod. So we have the IP address on which it is running, and we see that the Nginx is listening on the 80 and 443 ports. And now we'll create two deployments which this resource will serve. We'll open Visual Studio Code, and here are our two PHP applications. They are very simple. We have application version 1 in the first one, and in the second one we have application version 2. From those applications we'll create images with the following Docker files. Actually, we're using the HTTPD Apache server and we are transferring all the information from the local directory, such as the index.p file, inside of the user local Apache htdocs. This means that afterwards the image will have application version 1 inside. The same is for the application version 2. Now let's go to the terminal to create images from those Docker files. All right, so we'll go to the first directory, and here we'll build our image. We'll use the current context, so this directory. Then we'll give an image a name PHP app and a version 1 as a tag. And this is the special thing that we're using. Actually, this is required because afterwards we will need to push this image into the Kubernetes registry. We downloaded several layers from the HPD, and we copied our information inside of the image user local Apache htdocs. Now, if we take a look at the images, we'll see that we have successfully created this image. The same procedure we'll do for the PHP app2 directory. We'll just change the version to version 2, and now we have those images built. Now let's push the images into the registry. We'll first push the first image and then the second one. And now we'll create 2 deployments which will use those images from the local Kubernetes registry. Back in Visual Studio Code, let's take a look at the 2 deployments. In the first one, we're using version 1 of the PHP app, and we're giving a name of PHP app and an opening container port of 80. Then, based on this, we are building a replica set with 1 replica, and with the current deployment of a name of deployment web, we are targeting all the replica sets which have labels of app equals to PHP app1. Basically, we are targeting those pods. Very easily, we can increase the number of replicas, and our deployment will take care of the operation, scaling up the application pods. The same structure and syntax for the second deployment. And now we'll go to the terminal, and here we'll apply the deployments. The first one and the second one. And now we can take a look at what's happening inside of the cluster. We see our 2 deployments are created in the default namespace, and they are ready to be used. All right. The next thing is to expose those deployments as services. The main difference between a service and a deployment is that the deployment takes care of the creation and the scaling of the individual pods, and the service takes care of the networking aspects, such as communication between pods. A service can also be backed up by several different pods as her endpoints. So let's take a look at our services. As you can see, the first service is targeting PHP-app1, which is the pods with the same label app equals to PHP app1. Then it exposes port 80 and builds a web service. The syntax for web service 2 is identical. Let's run those services for the web 1 and for the web 2. Now we can again see the situation in our cluster. We have both of the services running, and they have the following cluster IP, which means that they can be reached inside of the cluster with the following ports. At this stage, it's crucial to check whether we have a valid endpoints for our services. This will allow us to verify whether they are connected to our deployments. So we'll type get endpoints, and we'll see that we have 2 pods which are connected to respectively web service and web service 2. We can get the pods. Now let's check the IP addresses of our pods inside of the deployment. And we see that we have a deployment with the configured 1 pod with the following IP address, which is linked to the web service. The same is true for the next web service. Once we are ready, now it's time to create our Ingress resource. This is its configuration. It's a kind of Ingress, and it has a name. This Ingress resource will be relying on this domain hello world. So when users are typing hello world and we are using the root domain, they'll be redirected to web service on port 80. And when they use the v2 at the end of the domain, they'll be redirected to the second web service. You can also use rewrites that can capture different parameters inside of the paths. Let's apply now this resource. We go to the terminal and we will apply the Ingress YAML file. We can check our current Ingress configuration with kubectl get ingress. We see that the hello world info is listening on port 80 on the localhost IP address. If we type curl hello world, we should try to reach this address, and our Ingress will be able to handle it and to redirect to our services. Since this is our local host and it points to nowhere, we need to modify our hosts file. So type sudo nano etc hosts, and here we'll create the following entry for the domain of hello world info that we would like to be handled by our localhost IP address. We save the file and again try to run the curl command. And we see the output from our first application, and this should be the output of our second application. Right now they have the same information inside, but I'm sure that you can easily correct the mistake and put your favorite application code correctly into a Docker image, push back the image to the registry and use it with the help of Ingress. This time we'll see how we can work with ConfigMaps and secrets in Kubernetes by connecting a simple application from one pod to another, which is running MongoDB. So let's see what we have right now in our cluster. MicroK8s kubectl get all namespaces, and we'll see that we have enabled registry and DNS. And so you can do so with a MicroK8s enable registry and DNS. Let's take a look at our source code of the applications that we will be putting in containers. So basically we have one index.html file where we have a simple button for adding and deleting a quote, which requires the following main.js file. The functionality of this file is that in the beginning it fetches what we have inside of the API URL quotes, and also it responds to the click of the delete button and the click of the add button. This is our server, which is serving the APIs. So we are using Express and Mongoose. What's important in this file is the connection to the container. We are doing this by using environment variables, and we're using, as you can see, MongoDB admin username, admin password, and MongoDB DB name. We're placing this object of options inside of our connection string. Here you should remember to put the name of your MongoDB service after it has been created. Later the code is responding to the request by just fetching from the database, creating new ones, as well as deleting quotes. We have a package JSON where we have 3 stages. For development, we are running Babel in order to parse our ECMAScript 6 syntax, and then we are running Node Monitor in order to reflect the changes of our code so that we don't stop and restart the service when we make changes to the code. If you would like to preview what is happening after the content has been built inside of the dist folder, we run node dist index.js. So basically Babel is taking everything inside of the lib folder and is compiling and transpiling the JavaScript into the dist folder, and we are using it together with NodeMon and Node, depending on whether we would like to be developing code or producing final version. If you open our development tree, we'll see that we have one directory lib where our index.js server resides. In the dist folder, we have our index.html, so the core of our website, together with the public visible main.js. We expect Babel to compile index.js and transpile it inside of the dist folder. If we open up terminal, we can run the following command: npm run build. This is actually producing the code into our dist folder. Now we see that we have a new file which is index.js, and inside of this file we can see that it's more verbose and our node can interpret it successfully. One more thing to see here is the Dockerfile. We're basing on Node Alpine version. Then we are changing to the app folder inside of the image. We're copying our package.json file there, doing the required package installations, and we're copying all our files inside of the app folder of the container. After everything is ready, we're running the following command. This will run our index.js server. Okay, let's take now this Dockerfile and create an image out of it. We'll go to the terminal. Here is our server. we can use the following command in order to build an image out of this context. So we use docker build, take into account all those files, and tag our image with the following information. Localhost 32,000, which is the name of our local registry, and then the name of the image will be Mongo app version 3. This will be the tag of the image. All right. The next thing is to push this image into the Docker registry. So we can type docker push, and then we'll type the name of the currently created image. So localhost Mongo app version 3. All right. It's now inside of the registry of Kubernetes, and we can read it. When we have our image in our registry, it's time to look at our configuration files for Kubernetes. For our application YAML file, we are creating one deployment and one service, which will expose the deployment. For the deployment, we have only one replicas, and we are tagging our deployment with the name of Mongo Express. As you can see, we're using the currently created application, which was localhost 32,000 Mongo application version 3, and we're exposing port 3000, which is the default port on this application is listening on. Then we have configuration, which grabs variables from the environment. This configuration describes secrets and ConfigMaps. Why we're doing this? Because otherwise, if we provide directly the secrets here, first they'll be visible to anyone who has our YAML file. And second, when we apply them, the administrator of the Kubernetes cluster can also see them. That's why we're using secrets where we will encrypt those passwords. We'll show this later. Now to the service. Once the deployment is created and we are sure that we have available pods for our containers, we need to find a way how to expose those pods to be able to interact with other pods. So that's why we are grabbing the port 3000, which is the container port, and we are specifying it in the target port, and we are exposing it to the cluster. We are naming the service with Mongo Express service, and the most important thing is that this service will only select pods which have the following selector app equals to Mongo Express. If we take a look here, we will see that we're creating exactly the same pods with app equals to Mongo Express labels. All right, let's see now what's inside of our secret and how it connects to our deployment. So here we're describing our secret and it has a name. In the data section of this description of the secret, we're specifying base 64 encoded version of my username and my password, which I would like my container later to use. When we have MongoDB secret as a name, inside of our deployment, we can specify environmental variables which will be directly integrated into the container, and those values will be taken from the MongoDB secret. Then we would like to focus on the key Mongo root username. So we'll focus on Mongo root username, we'll read its value, and we'll bind it to the MongoDB admin username. The same will happen for the MongoDB admin password. It will be bound to the key Mongo root password inside of the secret. ConfigMaps are interesting because they can share common values inside of different containers and services. The syntax is the same as the secrets. We're specifying this time that it's not a reference to a secret key, but we're specifying a reference to ConfigMap key. And here it is. We're specifying that this is ConfigMap. It has a name, MongoDB ConfigMap. Here it is the name. And we're looking for the key, which is database name. The database name key is here. And this is the name we would like to create. So this way we'll be able to pass this quotes value inside of an environmental variable MongoDB name. Later, when a container is started, it can read from this variable. As you can remember, if we return to our code in the index.js, we are using the environmental variables hidden inside of process.env, and we're using MongoDB admin username, admin password, and DB name in order to connect from our application to the container. Those three values are set up here inside of our deployment. Okay, one more thing to remember is that we need to create the secrets and the config maps before creating our deployment because our deployment depends on them. Last but not least, we'll discuss our MongoDB server. Here we're creating one deployment and we're using an image of MongoDB. It will be downloaded from Docker Hub. This image is characterized by the port of 27017, so we can initiate connections towards this port. As you can see, we're using again the secrets such as root username and password in order to set up the initial root account inside of the MongoDB container. Then, the same way as we were exposing the Mongo Express deployment, this time we're exposing the MongoDB as a service. We're mapping the internal port of 27017 and we're exposing it as the same port inside of the Kubernetes cluster. Let's now apply those configurations using kubectl and see if our application will run smoothly. We'll go to the terminal. Let's list the configurations. First, we'll create the config map and the secrets. So we can type MicroK8s, kubectl apply -f, mongo config map, and then mongo secret. Now we can type MicroK8s, kubectl describe secrets, and we see that root password and root username have been created. Then we can describe config maps, and we'll see again that we have our config map successfully created. Next, we'll apply the configuration of the MongoDB container. MicroK8s, kubectl apply -f, mongo YAML. Let's take a look now at the status of our cluster. MicroK8s, kubectl get all in all namespaces. And here we can see that not only we have the registry and the DNS hotspot running, but our MongoDB deployment is also running. And what's left is to apply the Mongo Express configuration, which will connect to the MongoDB servers. Okay, let's once again take a look at the cluster. We see our Mongo Express application and service running. It has a cluster IP and it's of type NodePort. We can even see our services by typing MicroK8s kubectl get services, and let's describe our Express service. MicroK8s kubectl describe Mongo Express service, and it's type service in this namespace. And from here we see that for this service, Mongo Express service, we have one endpoint which is responsible for it with this IP address. So let's check this information by getting information of our pods. And we can see that exactly Mongo Express pod has the same IP address. So it will be responsible for this service, Mongo Express service. Another thing to notice is that when we type get services, we see here that our MongoDB service is also available. And with the help of the internal DNS, we can reference directly MongoDB service by its name. Here in our code, when we're connecting via Mongoose, we're using the name of the service. So this will immediately resolve the service. So if I type describe MongoDB service, we'll have to be forwarded to this pod. This way, we don't need to know the exact IP address and port of this pod in order to connect to it via the MongoDB, but just by knowing its service name, we can connect very easily to the container running inside of the pod. All right, so from the services, we can use both of those ports. This is inside of the container. This is also browsable from our node because we're running on localhost. So let's try to run our application now. All right, we'll use the port 3000 and we see our application running, so we can add favorite quote, and we see that it's adding the quote. Also, the application can delete the last quote. Basically, we saw how we are interacting from one front end, from one container within one pod to another container where our database resides. And the most important for this lecture was the usage of secrets, so that we are not exposing our credentials to other users. Let's see how we can do automatic deployments and development using Skaffold. So we can go to the website skaffold.dev And from get started, we see that we have installing Skaffold. So basically we will need to run those two commands. Afterwards, we will have our Skaffold executable running and placed properly in our Linux path. Let's go to the command prompt, and now we should be able to run Skaffold, the command. All right, so I've chosen a project consisting of a PHP file, which I'll be changing, and it will automatically create image out of it and redeploy it into a container. Let's see this structure in Visual Studio Code. So here is the contents of our index.php. It's just a simple PHP file. Then we have a Dockerfile from which we are using the PHP CLI. And basically we are getting everything that we have in this directory. So all those files, we are copying them into the app directory inside of the container. Then we are changing into this directory, and we are running the built-in PHP web server, and we are exposing port 4000. So this way our index.php will be loaded when we load this address inside of the container. Then we have created one pod based on the container. What's specific for it is that it has a name. So this is the name of the pod, Skaffold pod. It uses a container Skaffold CNT, and since we are running a secure image using MicroK8s, we'll be using the following address, localhost 32,000, and then the name of the image we would like to build. That's basically for the pod creation. The next thing we will need in order to be able to run a Skaffold is the YAML file. And this is how it looks like. The nice thing is that we can generate it directly in the terminal. So if I go and run the following command Skaffold init, we see that we already have a configuration. But let's say that we delete this file and again issue the following command, and we see that we are having absolutely the same information. We would like to write this into scaffold.yaml. I'll go to Visual Studio Code, and here in the Skaffold YAML file, I'll just remove this dash from here. So basically we'll be looking for this image, PHP app, to be created. So this will be produced artifact. And for the deployment, we'll be using our pod configuration. So we'll start a pod. We'll be looking for changes and rebuilding for this image. Now back to the terminal. We need to adjust some more things. So the first thing is to enable the MicroK8s registry. And then we would like to check whether it functions properly. So we'll try to browse its address, its localhost on port 32,000 and v2. When we see that we have a response, this means that everything functions properly, and we can provide this registry to Skaffold to be able to find our images. Before doing this, I will create a local alias. We will point MicroK8s kubectl to be able to invoke it with kubectl, because Skaffold is looking for this command to issue, and otherwise will create problems for us. So we're creating this alias, and now we can run directly kubectl, and that's the output of the same of MicroK8s kubectl. Now we are ready to run a Skaffold. Basically the command is scaffold def. Since we are inside of MicroK8s, we would like to set this default repo towards the address of our local registry. And as we can see in the beginning, it's looking for the cache for our image. It's not found, so Skaffold is automatically building the image based on the provided Dockerfile configuration. These are all the steps and the layer it is creating. Then it's tagging the image and pushing the image directly to the Kubernetes registry based on Docker. Then it's creating this localhost alias, and also it's running our pod. Now inside of the pod we have a container where we run our PHP development server. And we see the output that the server is started. The next thing we would like to do in order to be able to see the changes happening inside of the pod is to create a simple port forwarding. So let's first see our pods. So we type kubectl get pods, and we see that we have one pod here, Skaffold pod, which is our pod, and it's running. With the following command, we would like to port forward this pod and its opened ports. So we know that we opened port 4000 from this pod, and we would like to expose it to port 8080. Here inside of the Dockerfile, we see that we are running the PHP web server and it's exposing port 4000. So from the command prompt, we are doing this redirect. And now we can actually browse this address here in our browser, and it should redirect to the local port 4000 inside of our container. All right, let's see. And this is the output of our image. We see hello. Now everything is set up. We have access to our container. And let's see the benefit of using Skaffold. So we change something inside of in this PHP file, and we click on save. At the same time, on the other window, we will see how Skaffold will detect the changes. So let's save this file. And here automatically it starts the build process, creates the image into the registry, and patches our deployment to be able to reflect the changes from this image. Now, as you can see, it's watching for changes, but our image has to start the server once again, so we will need to wait a little bit. And after a few seconds, we see that again we have our PHP web development server started. And again, we can go now to our browser and refresh, and we see those are the updated changes we just did. All right, guys, now you can see the power of Skaffold and how it can be beneficial when building and deploying code inside of Kubernetes. Let's see how we can monitor a specific web application with the help of Prometheus. We will be using Nginx. So in order for Prometheus to be able to scrape the data, we need to pass the data using a specific metrics format. The Nginx Prometheus exporter allows us to convert the data to a Prometheus metrics data. So in order to use this Nginx Prometheus exporter, first we'll need to grab useful data of the website usage directly from Nginx. So this is our configuration. Since we are in a Kubernetes environment, we'll need to patch the configuration of the Nginx. We will be using ConfigMap. The beauty of this is that the moment we would like to change something into this configuration, we can reapply the config map and it will automatically restart our deployment, and Nginx will accept the new configuration. Nice to notice here is that we are revealing a page called Nginx status, and it will enable this step status, which is actually the produced statistical metric information for us. After we have configured the Nginx, let's see its deployment. Inside of the Nginx deployment, we'll be having two containers. The first one will be a pure Nginx server patched with our configuration. So we are loading up the configuration from a volume, and we're placing it inside of etc Nginx confd. This is our volume. Basically, we are loading up from the config map, Nginx config map. So from this name here, we're loading the values, and then we're grabbing the specific key default conf. So this key and all the data that we have in there, we are saving it into a default.conf file. And then this default.conf file will be using it inside of the mount path, so it can be visible inside of our Nginx web server. So whenever we are loading up the image Nginx, it will read the configuration and configure Nginx to produce statistical information. The second container with the name of adapter is actually using the Nginx Prometheus exporter. The Nginx Prometheus exporter is configured via the following arguments to scrape the Nginx status page. And if you remember, while browsing Nginx status, the Nginx will produce for us a statistical information. Okay, so this will configure our Nginx Prometheus exporter, and it will reveal itself on port 9113. Now let's go ahead and try to run this deployment in order to have those containers running. So let's display the default information on all namespaces for our cluster. So we have several pods, services, daemon sets, deployments, replica sets. Everything is coming from the direct installation of MicroK8s. And now we'll start applying first the config map. So I'll just type MicroK8s. kubectl apply -f nginx config-map YAML file, and we see that the config map is configured. We can get the config map, and also we can describe it, of course, with the config map in front. So we see here, this is the configuration which is loaded in memory and is waiting for our deployment to be able to use it. And now let's apply the deployment. MicroK8s kubectl apply -f nginx deployment, and we see the deployment is created. And now it's time to see what's happening in the cluster. We see our deployment, it's already available. Also, we have our pod configured. So we have 2 pods, one for our Nginx server, and the other is for the Nginx Prometheus exporter. All right, and now let's actually expose those pods using a service. Let's see the configuration of the service in order for us to be able to browse it later. So here we are targeting all the deployment pods which have a label of app equals to web server. So that's what we are targeting here, those 2 containers inside of the pod. What's interesting is that we are creating a named pod ngmon, so we'll be able to browse on port 8080, which the service will expose, and it will target the port 9113 inside of the container. And if you remember, this port 9113 was exactly the port where our Prometheus exporter is running. So we'll be able with the service to show the information directly from the Prometheus exporter. All right, so let's apply now the service. So MicroK8s kubectl apply nginx service, and we can actually get services and get endpoints. And we see that we have our nginx service, and it's pointing to the following container. This is the port inside of the container, and it's serving the Nginx service. And we can use the cluster IP and the port 8080 to browse the information inside of the Nginx service. Let's browse port 8080. We see this is the Nginx exporter. We can also see the metrics URL, and that's was our goal, to be able to export the information. And now the next step is to be able to feed this information inside of the Prometheus. So for this, we'll be using the so-called service monitor. So its goal will be to check with the interval of 5 seconds whether there is something new inside of our metrics URL, so on this service, and whenever there is something new there, to register this information inside of Prometheus. What's important here in the configuration is that you should use string name as here in order to connect the service monitor to the service. So here we are having a named port with the name of ngmon, and the service monitor also is using this port in order to connect to the service and start listening for updates and fetching those updates to Prometheus. Now let's apply the service monitor configuration. So type MicroK8s kubectl apply service monitor YAML, and we type -file. And here we see an error. That's because we haven't enabled Prometheus, and let's do this. So enable Prometheus, then I will be able to apply the YAML file because it's actually specific to the Prometheus. So I'll just reapply the service monitor manifest configuration, and we see now that it has been successful. And now let's take a look on how we can connect to Prometheus. So MicroK8s kubectl get all namespaces, and from here we'll see our Prometheus. It's listening the following IP with the port 9090, So I'll browse this service. Okay, we'll go to port 1990, and that's the Prometheus. And here, from the status, we can go to targets. And here we see a lot of predefined targets for monitoring the whole cluster that we're having. And now let's find our application or our Nginx. And as you can see, this is our target, and this is the endpoint. So basically, the metrics are being successfully read and scrapped by Prometheus. So that's how. From here, you can make queries on the data and also display the data using Grafana. Okay, let's see how we can use Helm in order to simplify the process of creation of development and production environments. We'll issue the following MicroK8s, enable DNS and Helm. We'll need both of the services, and we'll be using the version 3 of Helm. I've already have enabled those. We can see what's inside of our cluster by typing ts kubectl get all -a. Here we have the core DNS, which is provided by the DNS. If we type MicroK8s inspect, we should be able to see all the services running by the MicroK8s status. We should see that also the Helm tree is enabled. I've used the following command. So it is Helm tree create a project chart, and this will automatically scaffold a chart project for us using Helm, and that's the basic structure that we have. So we can open this inside of Visual Studio Code. So that's the project structure. We have templates and charts. Actually, I've deleted everything from the template and I have created my own. The way Helm functions is by reading all the values that we have from the values and the chart YAML files, and then pushes them up inside of predefined configurations that we have inside of the templates, and afterwards executes this, passing it to the Kubernetes. As you can see in the chart YAML, we have basic information about what kind of application we'll be distributing. And then I've added to the values YAML the following fields. So basically, I've created one environment, which is development. And as you can see, we have the Nginx, which will be on port 80 in our cluster. So nothing fancy here. Now let's see how a certain pod can be created. This is a configuration of a pod. And as you can see, there is nothing different here than just using secrets inside of the pod, which we are binding to certain directories. Later we'll show the secrets. For now, what's interesting is that by using those double curly braces, we are able to reference the values file. So with .values, we are referencing the values file. Then, for example, English repository will go to here to this entry and then to the repository. And it will actually reference this string here. And the same is here for values.env. It will reference the def here. So the main benefit that Helm offers is that we can change here dev to production and other types of environments, or we can create multiple files with values inside. Then we can have templates, and based on what we have inside of our values, the templates will be changed and will be rendered differently. So let's see now the config map. Here, as you can see, we're able to switch between two different ports and URLs based on the value of the def, which we are getting from the values file .env. And this way, if we go to the terminal and type MicroK8s Helm tree install, and then the name of our chart, which is project chart, and then we have to specify the current directory with the files. We'll be using this directory here that we are in. We see that the project chart has been deployed. And if we check right now the status of our cluster, we'll see that we have our pod running. And as you can see, the name of the pod is dev here. We can also see the config maps, and we can describe this config maps. So we can type describe config map, and then the name of the config map. And we see that we're using port 8000 and our URL is devprojects.com. Now, if we go back to our configuration, and here in the values, we change this, for example, to production, and we save and go back to the terminal, where we will refresh the chart by typing Helm 3 upgrade project chart, of course the dot, and we see that the revision is number 2. First, let's see what's happening inside of our cluster. Right now, we see that the pod is named production DB client pod, and that's because here in the pod we're using values.env, and that's now prod. The next thing we should see is that the port has changed to 80 and the URL is different. So let's get the ConfigMaps. So by typing MicroK8s, kubectl get ConfigMaps, we see that we have project chart, ConfigMap production. Let's see what's inside. Again, with kubectl describe, ConfigMap, project chart, ConfigMap plot. All right. And we see that the port is 80 and the URL has changed to our production URL. Now we'll focus on the secrets. So for the secret file, we see that we are creating 2 different username and passwords based on the environmental values. And here we are checking whether the environmental values equals to dev. Here we have dev. Then we'll have MySQL and admin as a password. Otherwise, there will be root and root. Those values, you know how to achieve them by just typing in terminal, for example, this, which will encode the output of admin into base 64. Now let's check the usage of the password. Here inside of the pod, we're using this secret and we're mounting it using a volume into etc secret volume. So our next goal is to log into the pod and to see whether we are able to browse the secret. By typing MicroK8s kubectl get pods, we see that we have this production DB client pod. So we can enter inside by typing kubectl exec with the interactive terminal. We'll enter into the pod prod and DB client pod, and then we'll execute bin bash inside. And of course, this will be with 1 dash here. So we are inside of the pod right now, which is running. And if we go to the etc directory to check our password, then go to the directory of secret volume, which is mounted. And here we see the password and the username. If we go and check what's inside of the password, we see the output here of root. This means that we have successfully mounted the passwords here. And at the same time, they are not exposed to the administrators of the cluster because they are saved in a secret. That's a very good approach when you are taking care of the storage of your passwords and their security. All right, guys, that was our initial experience with Helm. Of course, you can extend those charts and produce more sophisticated setups. I hope the information will help you to enjoy the benefits of Helm. Let's see how we can use Argo CD in order to write our configurations automatically to be synchronized and applied inside of MicroK8s. That's a very interesting tool. And let's start with its installation. Let's say that we already have MicroK8s installed. If not, we'll go to terminal. And here we'll just type sudo snap install MicroK8s. So here I have it already installed, and I'll add the following add-ons, which will be DNS and storage. Once they are enabled, we'll create a separate namespace for Argo CD. So I'll use this command, MicroK8s kubectl create namespace Argo CD. I've already created it, and I can get the namespaces, and we see that we have one Argo CD namespace active. Now inside of this namespace, we'll install the needed services, pods, and stateful sets for Argo CD. I'll not use the default provided command because it has problems right now with GitHub. But I'll go directly to GitHub Argo project Argo CD releases, and from the latest release, I'll just apply the install manifest. And of course, I'll prefix it with MicroK8s. And now we can issue the following command, MicroK8s kubectl get all with the namespace of Argo CD. And this should show us everything that is created. And we see that our services are running. Those are our pods. We have our Argo CD server, and we have also deployments and replica sets, as well as the stateful set for saving the configurations. and for communication together with our cluster. They are all used for providing user interface, as we can see here on port 80, the Argo CD server. Also, they're used in order to manage the state of applications which will be installed on our cluster. Okay, the next thing we'll do is to try to browse the server. So directly without any port forwarding, we can grab the cluster IP because right now we're trying everything on one machine, which is not exposed to internet. So we can browse this address, and here I'll just type address, and now we will accept the certificate, and we can log in with the username of admin, but the password for it, we'll try to grab it directly from the deployed configuration. So we have secrets, and we'll use the following string to extract the password from there. That's the string. Actually, we'd like to grab the initial admin secret. This is stored inside of configuration of the secret, and afterwards we'll decode it. So that's our secret. Let's use it here, and we should be inside of Argo CD. That's the interface, and as a next step, we will connect Argo CD together with a GitHub account. And the goal is to be able to push new configurations inside of GitHub, and the Argo CD to be able to synchronize those configurations inside of our local Kubernetes cluster. Here I have already connected repository. That's quite easy. You just use a preferred method. For example, using HTTPS, you just have to type the repository URL, and if you're connecting to a private repository, of course, you can use the username and password. Once this is done, we can create our first application. So we go to applications and we'll click on new application. Let's say that will be applying Nginx service and deployment. So we'll call it my Nginx. The project will be the default, which is used here in Argo CD. And for now, we'll be synchronizing manually. But of course, you can change these settings to automatically. Argo CD can monitor the changes and apply the new configurations. And for the source, we'll be providing our GitHub URL, and for the path, now you can either create a subdirectory inside of GitHub, or you can provide the default current directory path with dot. For the destination, actually we are providing our Kubernetes cluster, and the namespace is the default one. So that's what we need to configure. Basically, this will connect to our MicroK8s service, and will make changes to the default namespace. So basically we have Argo CD namespace for the configuration and the needed programs of Argo CD, and we have the default namespace where we will be applying our configurations. We can create our application. We see that it's created. It's connected to our repository, and for now it's out of sync because we haven't synchronized it with the repository. Now we'll create one directory inside of our machine, and we'll also connect it to the GitHub repository. And so whenever we are making changes locally and pushing those changes in GitHub, they'll be reflected back to Argo CD, and Argo CD will make changes to Kubernetes. Let's see how we can do this. All right, so we go to our GitHub account, and inside of our empty repository, I'll just clone it in the terminal. I'll just type git clone and then the URL address. This should create a new directory inside. What we have, there is nothing. Okay, let's create our configurational file. So we'll type nano Nginx YAML. Now it's time to use pre-configured configuration of Nginx server. I'll just directly paste it. Basically, we're having one deployment and one service exposing this deployment. We're using Nginx container from the Nginx image, which will create a pod, and we'll have two replicas of it. Afterwards, we'll be exposing everything on port 80 with Nginx service. Let's save the file, and now that's our configuration. Now we can type git add, and we can, let's say, add this file. The next thing is to commit it with a message of Nginx deployment and service, and we should try to push this into our repository. Now this file should be in our public GitHub account. If we refresh, we see the file, and that's the contents of the file. Okay, let's go to this application now. And when we click on refresh, we see that we have already a service and deployment. Let's try to synchronize it now. And we'll see that they will be read directly from the repository and will be applied. We see one replica set with 2 pods created. And let's check this out inside of the terminal. So let's type MicroK8s kubectl get all, and we'll see that we have the 2 pods running. Also, our Nginx service exposed here. So we can try to go to port 80 on this cluster IP and try to browse our Nginx server. Okay, and we see that's the output of the service. And now what's interesting is why Argo CD is so useful is because we can go ahead in our terminal and here create another configuration. Let's say we change something, we change the replicas to 1, we save this, and again we'll add our file and we'll push it with another message for commit. Okay, so we'll push it to Git. Now once it's in our GitHub account, we'll see what happens in Argo CD. So everything stays, but if we refresh, we'll be able to see that our current configuration is out of sync with what we have as a source of truth inside of GitHub. And actually, we can click on app diff, and if we click on diff, we can see that the replicas were 2, and now we change the replicas to 1, so we can see more granularly what is happening. And now we can synchronize everything. Keep in mind that this will just create a new pod without pruning the old ones. So we have those options here to be able to remove the old ones also automatically. So we click on synchronize and we see that only one pod is left and the other one was terminated. So now if we go in the terminal, we can check this. So if we go ahead and type again get all, we see just only one pod here. And that's basically how the process goes. We declare our configuration inside of configurational files, and then we make changes to them. We push those changes, and from then on, Argo CD takes care of keeping the cluster configuration synchronized with our desired state in GitHub. So now here on app details, we can scroll down and enable the automatic synchronization, which will do all the steps for us. So it will be able to detect all the changes and apply them automatically. And that's very useful. And keep in mind that you can also delete all the resources here directly from Argo CD, as well as the whole application, which will basically delete the configurations and resources directly from the cluster. So once this is ready, we here in the cluster will not be able to get anything from the current namespace except the default Kubernetes service for our cluster. How we can actually develop from our laptops without the need to constantly commit our code and create images and then restarting services and pods and deployments. We can do this with Telepresence, which needs initially to connect to our Kubernetes cluster, and then once it's connected, we'll be able to intercept certain services, thus redirecting our requests, enabling them to pass not through the ordinary services by redirecting them to pass through our services where we are developing our code. So let's see the demonstration of this on a server where we have already installed and connected Telepresence to our local MicroK8s distribution. Okay, here as a demonstration, on the left-hand side, we have our locally installed cluster. And we have one service which is called Hello Node, and it's of type load balancer, exposing our pod, which is also a Hello Node. So this is running on the cluster, and Telepresence has intercepted exactly this running service on port 9001. And now if I try to run a curl towards this address. So this is the address of the service which should go into the pod. It will show me empty reply from the server just because the interceptor of this service is now pointing to our locally running version on the same port. What I mean is that here I have the following contents of the program where I've modified the version of Hello Node, and it's version 5. And if I run the server locally, so if I run node monitor and then the name of the file, which is hello node, and will start serving us on port 9001. And again, I hit the IP address of the load balancer on this port. We'll see that we are skipping the default installation of Hello Node, which is running on the cluster, and instead we are running our local version. This allows us to connect to remote Kubernetes clusters, bypassing some of their services in order for us to develop them locally. It's very easy now to change something inside of this application, let's say the version. Of course, we can use an editor, and this is running locally. We are not uploading anything to the server. We are not creating images. We are not restarting deployments and creating new pods. And again, if we try to hit the load balancer IP address, we will see that right now we are testing with the new version, gaining enormous benefit by this way focusing only on certain parts of the application which we can install on our computer and develop using the real world cluster.